Welcome to your Algebra 2 Lesson 3.4. Last time we talked about solving systems of linear equations in two variables using algebraic methods. Today we're going to talk about solving systems of linear equations in three variables using algebraic methods, and you are going to need to keep your work very neat, and you're going to have to be very, very careful because sign errors are going to kill you. If you're not, you just have to be careful. You don't want to make a mistake along the way. So today's the day to super focus on what you're doing. All right, of course, our objective is to solve systems of equations in three variables. So what is a linear equation in three variables? Well, you've got x, y, and z, and it's an equation of the form ax plus by plus cz equals d, where a, b, and c are not all 0. A solution of such a system is an ordered triple x, y, z. So you're going to want to make sure your final answer, unless there's no solution, in which case it'll be no solution, is in an ordered triple x, y, z. All right. So there's three cases. There's one case where you have one solution, and that's where you're going to have that ordered triple x, y, z. And you can see there you've got three planes, intersecting in a single point, and that is one case. There could be infinitely many solutions where all three planes either lie right on top of each other or where they form a line. And we will learn how to come up with an ordered triple to explain these three or these situations. And no solution. So you either have parallel planes, planes that intersect where any two of them intersect, but not all three. So, or where two intersect with one, but not each other. So there are several ways you can get no solution. Okay, so the elimination method for the three variable system, you're going to rewrite the linear system in three variables as a linear system in two variables by using the elimination method. Then you're going to solve the linear system for both of its variables, and then finally you're going to substitute the values found in step 2 into one of the original equations and solve for the remaining variable. You can also use the substitution method if it's just easier, where in the first step you actually substitute in an expression for one of the variables in the other two systems. If you obtain a false equation such as 0 equals 1 in any of the steps, then the system has no solution. If you obtain an identity such as 0 equals 0 in any of the steps, then there are infinitely many solutions. And last time when we were just doing two variables, we just left it as infinitely many solutions. Today we're going to see how we can actually come up with ordered triples that explain that the infinitely many solutions that actually work. Okay. So let's look at examples. So let me move to the example PowerPoint. And we will do one example and then we'll stop, and that'll be the end of video 1, and then we'll look at the last three examples in video 2. All right, for example 1, we're going to use the elimination method. So we're going to solve the system. We've got three equations. You want to number the equations. I usually put the number like in a little circle. So next to 4x plus 2y plus 3z equals 1, to the left of that I might have a 1 in a circle, and then 2x minus 3y plus 5z equals negative 14. I might have a 2 in a circle next to that. And then I would label that third equation with a 3 in a circle, 6x minus y plus 4z equals negative 1. All right, for your solution, what you're going to do is you're going to pick a variable to eliminate, okay? And that's just like you did before when you just had two variables, and that's going to be the one you look at and you go, okay, I want to try to get opposites in front of that variable, okay? I want coefficients that differ only by a sign. So in looking at this, it looks like y is going to be the easiest one to work with, because if you look in that third equation, we have a y that has a coefficient of negative 1. So it's going to be really easy to multiply that third equation to make it match up with the other two equations. So what I'm going to do for my first new equation, because I want to rewrite the system as a linear system in two variables, I'm going to try to eliminate the y. And so to do that, I'm going to multiply equation 3 by 2 so that I can add it to equation 1, and I'll have negative 2y to add to 2y, and my y's will go away. So I'm going to add 2 times equation 3, which gives me to equation 1. So if you look here, we rewrote equation 1. So equation 1 is just written as 4x plus 2y plus 3z equals 1. And then we did twice equation 3. Well, 2 times 6x is 12x. And then minus 2y plus 8z equals negative 2. So everything in equation 3 got multiplied by 2. Now we're going to add those two equations together, and that's going to give me a new equation 1. And the way I write that is I put a little star and then a 1, and I put that in the circle. So I've got 16x, 2y minus 2y eliminates the 2y, which was our whole goal, plus 11z equals 1 plus negative 2 is negative 1. So that's my new equation 1. And so you want to, like I said, I like putting a little star and a 1 and putting a circle around them, and that way it makes it real easy to come back and find it. Now, because we eliminated y in this step right here, we need to eliminate y when we combine 2 more equations. Now, we combined equation 1 and equation 3 this time. Now we have a choice. We can combine equation 1 and equation 2, or we can combine equation 2 and equation 3. Okay? We can't combine 1 and 3 because we've already done that. So our other options are 1 and 2 and 2 and 3. Now remember, we're getting rid of y. We have to be consistent with that. We have to get rid of y this time also. So I want to stick with using equation 3 because it's so easy to work with. So I'm going to combine equation 2 and equation 3. All right, to get opposites in front of my coefficients, I need to multiply equation 3 by negative 3 because I need to change the sign there. And then I'm going to add it to equation 2. So for equation 2, we had 2x minus 3y plus 5z equals negative 14. And then negative 3 times equation 3 gave us negative 18x plus 3y minus 12z equals 3. So I'm going to add those together. And that's going to give me a new equation 2, which I'm going to mark with a star and a 2 and then circle it. So 2x minus 18x is negative 16x. Negative 3y plus 3y zeroes out, which was our goal. And now we've got 5z plus negative 12z is negative 7z. And then we have negative 14 plus 3 is negative 11. All right. So we've got our 2 new equations that are just in terms of x and z. We can solve linear systems in terms of x and z, and from here you can either continue with elimination or you can switch to substitution, doesn't matter. But when we look, we've got 16x plus 11z equals negative 1, negative 16x minus 7z equals negative 11. Now, sometimes you're going to need to multiply one of the equations by something. This time, it works out great because we have opposites for our coefficient for x. They differ only by a negative, only by the sign. So we don't have to even multiply these by anything, but sometimes you will. You'll have to do that, just like we did in the last section. But anyway, for now, we just get to add these two together. If you've marked them like I have said that I do, you would have your 2 star equations that you combine. But anyway, so 16x plus negative 16x eliminates the x's. You get 0x there. 11z minus 7z gives you 4z, and negative 1 plus negative 11 gives you negative 12. Divide both sides by 4. And that gives you z equals negative 3. Now, what you want to do is you want to take that value for z and plug it into either one of the new equations, the equations in 2 variables. I did it in the first one, the 16x plus 11z equals negative 1. Now, on the slide, next time I click this on the PowerPoint, it's going to give the answer. But what I want you to do is I want you to pause it. And I want you to actually plug in negative 3 into 16x plus 11z equals negative 1, and I want you to see what you get. Okay, so pause. All right, great. So let's talk through what we did there. We plugged in negative 3 for z. So we had 16x plus 11 times negative 3 equals negative 1. So 16x minus 33 equals negative 1. So we add 33 to both sides, and we get 16x equals 32. Divide both sides by 16, and we get x equals 2. Okay, that's what they got. They just didn't go through the whole process for you there. That's why I wanted you to stop and do it, and then I wanted to talk you through it. All right, so now we know we have a value for x and we have a value for z. We can take those and plug them into any of the equations that we started with and find the value for y. So let's do that in equation 3. So we're going to substitute x equals 2 and z equals -3 into an original equation and solve for y. It doesn't matter which one. So just to be different, we're going to do 3. So you write out the original equation. So we have 6x minus y plus 4z equals -1. So we're going to substitute in the value for x and the value for z. So we're going to have 6 times 2 minus y plus 4 times -3 equals -1. And we're going to solve for y. Okay, so y is going to equal 1, but let's just talk through it a little bit. 6 times 2 is 12. Minus y, and then we have plus 4 times -3 is -12. Well, 12 minus 12 is 0, so we end up with -y equals -1. Divide both sides by -1, and you get y equals 1. So your final answer is going to be the ordered triple 2, 1, -3. So you want to write parentheses 2, comma, 1, comma, -3. And everybody knows the first number in that ordered triple is x, the second number is y, and the third number is z. Okay, so make sure you write your answer, even though on this PowerPoint they don't, write your final answer as an ordered triple. So you want to put in parentheses 2, comma, 1, comma, -3. Okay, that's it for video 1. We'll meet back together here in just a minute and we'll do video 2. And we'll finish out the examples.